Hey guys, welcome back, and today we're going to be doing a review of graphing sine and cosine, just kind of putting it all together. Even though we kind of already did it, I just feel like it was beneficial to spend an extra day on this stuff. So for the think/warm I have, could you write a cosine function that is equivalent to y equals the sine of x? Well, the answer is yes, right? And that's if we scooched it over to the right or left, I guess it doesn't really matter, pi halves, right? Because what's the sine? The sine function is like that, right? Where that's 2 pi, and that's pi, and this is pi halves, and this is 3 pi halves, right? Now let's think of the cosine. Cosine starts up top, then we go down, and then up, and that's 2 pi, pi. 0 is supposed to be pi halves, and this 0 is supposed to be 3 pi halves, right? So if we move this to the right, pi halves, really remember this one would extend downward like that. So if we move that to the right pi halves, then we're going to get our sine function. So with a phase shift of pi halves, we are going to get something that looks exactly the same as just y equals the sine of x, right? And we knew that, right? We knew that sine and cosine looked just like each other, that they were just a little offbeat, right? Cosine was just shifted over a little bit, and it's in fact shifted over pi halves. So I'm just putting this up here again, just in case we need it. This is everything we need to know about sine and cosine, right? The amplitude, the period, the phase shift, and the vertical shift. This is everything we need to know. It was up on the last one, so I'm not going to really go over it. But if you want to, this is another opportunity to write it down. So example 1, graph y equals 8 times the sine of 2x. Well, I'm just going to go step by step, and our amplitude here is 8, and our period is 2 pi divided by k, which is 2 pi divided by 2, so just pi. And so those are the only two modifications we have to this. So our amplitude is going to be, maybe we can go by 2's, 2, 4, 6, 8, negative 2, negative 4, negative 6, negative 8. And then our period is pi, so I'm going to make my n tick pi. Cut my halves in half. This will be 3 pi fourths. And then for the sine, we start here, go up, come back down. There we go, just like that. And that's all that one is. Now this one, a little more involved. So now we have an amplitude. The absolute value of that is 5. Our period, 2 pi divided by k, which is 4 thirds, which is the same thing as multiplying by 3 fourths. So really we're going to get, when we multiply by 3 fourths, we're going to get 6 pi, 2 pi times 3 divided by 4, which is 3 pi halves. So kind of a weird period. And then our vertical shift is 4. And thinking about that vertical shift, if we move up 4 and our amplitude is 5, we're going to need a lot more space above than we are below. We are going to need a little bit below, but I am going to make most of my space for up top. I know, again, vertical shift, I'm going to have to go up to 1, 2, 3, 4, and I know I'm going to have to go 4 above that, which is 1, or 5 above that. 1, 2, 3, 4, 5, and then that would put me at 9. And then I also know that I'm going to have to go 5 below. So if I'm at 4, that's 1, 2, 3, 4, negative 1, and 1, 2, 3, and then here's 4. So I know that my midline is at 4 because of my vertical shift, and then I also know that because of my amplitude, that's where our max is, and this is where our min is. And now our period is 3 pi halves, so that's my end tick. So 3 pi halves, cut that in half, cut that in half, cut that in half. You don't need to label all these, but halves and half is going to be fourths. Halves and halves, again, is going to be eighths. Then this would be 9 pi eighths. Yeah, 9 pi eighths. Doesn't really matter. You don't really need to label those. You really just need the ticks or just the end mark. Cosine, you start up, and then we move down, down, up. And remember, it's swirly. It's not like a V, so try and make it swirly. Here's another one. We know that the amplitude is the absolute value of A, which is just going to be 3. We know the period is 2 pi divided by K, and K is 5 halves. Dividing by 5 halves is really like multiplying by the reciprocal, so that's going to be 4 pi all over 5. And then vertical shift of a negative 1. So we know the vertical shift is negative 1, and I know I'm going to have to go 3 above that, so 1, 2, 3 at 2. And I know I'm going to need to go 3 below that, which is 1, 2, 3, which should be at negative 4. And I'm just going to get my midline and stuff there right away. I know my midline is at negative 1, and then I know my max and mins are at, my max is at 2, and my min is at negative 4. And I'm going to move that up a little bit just because it doesn't look, there we go, it looks a little better. And then I know that my period is 4 pi fifths. So out here is 4 pi fifths. And this time I won't worry about the labels in here. Negative cosine means we have to start down here, right? And then we're going to work our way up to our midline, and then our max, down to our midline, down to our minimum. All right. And that's all that one is. One more here. Again, our amplitude is just going to be 6. Our period, this is where this one gets a little different. Our period is 2 pi divided by 5 pi halves. Is going to be like multiplying by the reciprocal, so it's going to be 4 pi all over 5 pi. Pi's are going to cancel, and we're just going to have 4 fifths, which is weird because we usually like to have a pi in there, but the pi's cancel out, so it's just 4 fifths. and our vertical shift is 21. If our vertical shift is 21, I know I'm really just going to have positives with an amplitude of 6. Maybe I'm going to go by threes, so it'll be 3, 6, 9, 12, 15, 18, 21, and then I'm going to have to go up 6, which is really 2 more ticks, right, if I'm going by threes. So if that's 21, up by 6 more is going to be 27, and down by 6 is going to be 15. My midline is at 21. My new max is at 27, and my min is at 15. And I'm just going to scoot this up a little bit just so it looks a little more even. And then lastly, my period is 4/5, so that would be my end tick. Again, I'm not going to worry about the other ticks. If you want to fill them in, you can, right? This will be 4/10, which is the same thing as 2/5, half of 4. That's going to be 1/5, and this is going to be 3/5. Positive sign, so we're going to start at our midline. At the next tick, we're up, and there, and there, and then there. It's a pretty good sine function, drawing that on a tablet. And then the last example we're going to go through is writing an equation of this trig graph. The first thing I like to do is I just like to spot the midline. This one looks like it's going to be at 3. So we know that our vertical shift is 3. We know this is a cosine function because these ones aren't going to give you any phase shifts, because otherwise you wouldn't be able to tell whether it's cosine or sine. We know it's cosine because it starts out up top, so we know it's cosine. What else do we know? After one period, we are at pi, so the period is pi. And then we know the amplitude is 1, 2, because we go 2. So the amplitude is 2. We'll even do that. But we have to be careful here, because our period is pi, right? But our period was 2 pi all over k. And we know that we have this a times the cosine of k theta plus h. I'm leaving out the phase shift because these ones don't have phase shift, so we need k, right? So we're saying our period is this, which is equal to pi. So solving for k, we're going to multiply that k over and then divide the pi, and then the pi's are going to cancel. K is going to be 2, right? Or you could say 2 pi divided by what gives me pi. 2 divided by 2 is going to cancel out and give me pi. So then that's everything we need. Our amplitude, we said, was 2. We know it's cosine. Our k is 2 theta, or this one's probably going to want it in x, right? Because our x-axis, this is an x-axis, not a theta axis. 2x, and then plus h, our midline is 3. And that's going to wrap it up for reviewing sine and cosine, the graphing of it.